Good morning all. Now I am going to explain about input and output characteristics of transistor in CE configuration. Now see, first of all we need to connect input characteristics of common emitter configuration. Okay, this is the circuit diagram for CE configuration, right? That means first channel 1 RPS positive, RPS negative, second channel RPS, right? Next for input voltmeter and input ammeter. Next for output voltmeter, right? Input characteristics are plotted between input voltage versus input current by maintaining output voltage as constant. Now see here, first of all RPS positive is connected to resistor 1 kilo ohm starting point. Next this 1 kilo ohm ending point is connected at one point, right? At that point input ammeter positive is connected. Next ammeter negative is connected at another different point. Okay, at that point voltmeter positive is connected. Next voltmeter negative is connected to ground. Okay, voltmeter negative is connected to ground. Next ammeter negative and voltmeter positive terminal, at that point only transistor base is connected, right? Now see here, emitter notch, right? I am connecting like this. Here emitter base is connected at ammeter negative and voltmeter positive point. Okay, next this emitter should be connected to ground, right? See here, where emitter point is connected, at that point only that point is connected to ground. Next collector to transistor collector. At the transistor collector point another 1 kilo ohm resistor starting point is connected. This 1 kilo ohm resistor ending point is connected at one point. Okay, next at this collector terminal only output voltmeter positive terminal is connected. Next output voltmeter negative terminal is connected to ground. Next channel 1 RPS negative is connected to ground. Next at 1 kilo ohm resistor ending point, RPS positive is connected. Next RPS negative is connected to ground, right? Ground is having 5 terminals, 1 2 3 4 5, right? Now connections are over. Okay, next coming to the procedure. Connections are made as per the circuit diagram, right? After that switch on the power supply. Okay, switch on the power supply. Now see here, for this input characteristics, first set output voltage as constant, right? That is VCE is equals to 0. Okay, for VCE is equals to 0 we need to vary the supply voltage in steps of 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, right? Now current is increasing, right? 0.6, 0.2. Next I am increasing the supply voltage. See here, voltage is 0.7 but current is increases. I am increasing the supply voltage but voltage across the transistor is 0.7 only. Current flowing through the transistor is increases rapidly, right? I am increasing the supply voltage to 15 volts, right? See here, RPS supply voltage is 15 volts but voltage across transistor is 0.7 only. Current is 6.7. Current is rapidly increases. Next 20 volts, Yes, current is 9.2 milliamperes, but voltage is constant. That means if you see here, if you plot the graph between input voltage versus input current, right? Okay, now see here the graph. Up to certain potential current is 0, right? Already observed up to 0.6 current is 0, right? After it reaching 0.6 to 0.7, current flowing through the transistor is increases rapidly, but the voltage across the transistor remains constant. Okay, that is first case when VC is set to 0 volts, right? After that reduce RPS voltage to 0. Okay, next set VCE voltage, that is output voltage set to 3 volts. Right, output voltage is set to 3 volts. Okay, next again by maintaining output voltage set to 3 volts, after that next again increase the input value of voltage, right? See here, previously at 0.6 we are getting 0 only, here 0.6, here we are getting 0.2, next 0.7, 0.6, right? 0.7, 1.1, 0.7, 1.6, 0.7, right? I am increasing RPS voltage, but the voltage across transistor is remains constant, right? See here, RPS voltage is 10 volts, but voltage across transistor terminals will be, input terminals is 0.7 only, current is 4.4. Again I am increasing this RPS voltage to 15 volts, right? But the voltage across transistor input transistor terminals will be 0.7 only, current is increases similarly for 20 volts, right? Current voltage is 0.7 to 0.8, but current is increases very large. Okay, in this way we can plot the input characteristics by maintaining output voltage as constant. Similarly set output voltage to 6 volts, right? Before going to that one, reduce RPS, channel 1 RPS to 0, right? After that set output voltage to 6 volts, right? Right, for this 6 volts, next we need to vary the again RPS voltage in steps of 0.1. see here 0.30, 0.40, 0.50, 0.6, also 0, right? Now see here current is increasing. Next, now I am increasing the RPS voltage, current is 1, but the voltage across input transistor terminals will be 0.7 only. I am increasing this RPS voltage to 5 volts, right? 5 volts. Voltage across transistor terminals will be 0.7, current is 2.0. Again I am increasing RPS voltage to 10 volts, right? Voltage is 0.7 only, current is 4.4. Next, voltage is 0.7, I am increasing the supply voltage to 20, right? Voltage across transistor is same, or 0.7 to 0.8, very slight change, but current flowing through the transistor is rapidly increases, right? After that reduce RPS voltage to 0, input side as well as output side, that means channel 2. Okay, after that switch off the power supply. Okay, in this way we can plot the graph for input characteristics. Okay,